Hi, welcome to YouWillUnderstandMath.com. Today you will understand the definition of the limit. Suppose we have a function, say f of x equals x squared minus 1 all over x minus 1. Well, if you tried to plot points, you would have a problem when you try to substitute x equals 1. Because when x equals 1, we have 1 minus 1 in the denominator, which makes our function undefined. Well, this is a perfect scenario where we would use limits, because when we apply limits, we do not need to know what the output is at a certain point, but we can still gather information around that value. Notice our inputs, the x values here. I'm moving in increments of 0.02 units before 1 and after 1. We get these values. The only problem is when we plug in for 1, as I mentioned before. When we plug in for 1, we have a hole here. There's an undefined point. We don't know what that value is. So let's zoom in on this value here, and we're going to analyze what's going on. You see here, we've zoomed in to this function f of x equals x squared minus 1 all over x minus 1. We've taken a tiny interval around this value that we're interested in, where this hole is. We take this zoom, and I've only moved 0.02 units above the value of this hole, below the value of this hole, to the left of the value of this hole, and to the right of the value of this hole. Now, of course, these intervals may change, but these are the intervals that I've chosen. I have a little scale here with my inputs on the bottom and my outputs on the top. Notice when x is 0.98, f of x is 1.98, and so on and so forth. As we get closer and closer to 1 from the left, it looks like the outputs are approaching 2. As we move closer and closer to 1 from the right, it looks like the outputs are approaching 2 as well. If we zoom in on a tiny interval, and if the values of the inputs move closer and closer to a certain value, in our case 1, and the outputs move closer and closer to a certain value, in our case 2, then that value of the outputs is considered our limit. The limit of x squared minus 1 over x minus 1 as x approaches 1 is 2. This is the notation that we will use for limits. No matter how small the distance is that we move away from the point of interest, we can always find some value, some input for which the output is always in that small interval. In our case, for example, even if we wanted to find out what the output was when the input was somewhere here, let's say 0.99992 or so, okay? If that were the case, I could find an output which is somewhere here, which is still approaching the value of interest. If I were to find a value, an input here, let's say 1.00000 whatever, I would still be able to find an output on our function which is still close to the value of interest. So no matter how small an interval is above or below our point of interest, I should always be able to find some input so that the output is still within that interval. For example, these points are still within our box. In the next video, I'll show you the generic definition for the limit, the geometric representation, as well as what it means as far as the symbols are concerned, and I'll break all of those details down for you. Thanks for watching. Please subscribe and or like this video.